This is the recording for the Unit 4 pre-lab. And question 1, of course, you, the student, should attend the lab intensive. Then you look at the labs for Unit 4, so the center of mass, or torque, or mobile. The objectives, there are 3 of them. So make sure to look at the lab manual. That's the idea of the pre-labs. Then in the theory part, you will find that the torque, tau, Greek letter for that, around an axis of rotation is the vector cross product of the lever arm and the force. And you might already know that the torque is force times lever arm. Since the mobile is supposed to be balanced, the sum of the individual torques add up to 0, and therefore it's in rotational equilibrium. And of course, since it's an experiment, it's not going to be exactly 0, but it should be really close to 0. Furthermore, the balanced mobile, each segment's center of mass coincides with a pivot, and therefore by defining the pivot at 0.0 centimeters, you should also come up, when you measure it, at 0.0 centimeters within measurement error. So those are the 3 answers. Still the same lab. Procedures. These are some of the things that students have done wrong in the past that we needed to correct them. So pay close attention to that. It should be the correct order here. A, B, C, D, all the way through to I. So you have to measure the mass of 4 objects and 3 rods. You have to measure 6 distances from string to pivot and 3 distances from the middle of a rod to the pivot, and you will see that the data sheets are quite complex, what you have to fill in. When you measure distances from the left of a pivot, you must attach a negative to your measurement. Measure the distance horizontally from the pivot point to the object and to the middle of the rod. Left negative, right positive, and so on. You can read through this yourself, and again, look at the lab manual. Still the same lab. This is the example that is posted in the lab. You should find these numbers listed here. All of them should apply. Then the other lab is the centripetal force. These are the objectives. There's only one. And then in the theory part, the derivation of the centripetal acceleration. A centripetal acceleration equals velocity squared over radius is based on geometry, and then you can look this up at hyperphysics here. And Newton's second law, sum of the force equals mass times acceleration, is in this case then the centripetal force equals mass velocity squared over r. Whereas centripetal force itself is not a unique force, but it must be something else, like a support force or friction, or in this case, it's a tension along the string. These here, for at least some part, will be are the correct order here. So still the same lab procedures. Where does the piece of tape need to be while the mass is rotating? Right beneath the lower end of the tube. Look at the procedures in the lab manual. You should perform this experiment outside. We have it, and away from anything that could break, so away from windows, away from cars, because you are swirling something on a string that could potentially break. Fortunately, I think we're going to use rubber stoppers that you swing around. For each trial, you have to measure mass, length, number of rotations, time, and force. It's quite a complex experiment. It also has a large error attached to it. You will find that out. When moving on to new measurements, you can either alter the length or the mass. Usually we have it all supplied. Where does the piece of tape need to be while you're measuring the length? And that's the same answer here, right beneath the lower end of the tube. If you use an extended rotating mass, then make sure to measure length from its center of mass. And since the experiment is very dynamic, as you rotating a mass holding onto it. And I just mentioned that the error could be somewhat larger. You will find that out. All right, the example that is posted for this lab, 3 of these apply. Look at the numbers. These statements down here, they may be actually correct, but they're not posted as the example in the lab manual. And that's the recording for Unit 4 pre-lab.